Hello dear students, greetings from Konar classes. Today we are going to discuss that integrals of some particular functions, okay, and these are the 6 functions I have written here. Now whatever you see in this one, these are the result of this integration. So these are the formulas also you can think of, and you need to remember these formulas so that you can apply these formulas to solve questions. Now what I am going to do is that I am going to derive this formula, how this formula is actually being derived. So this knowledge is also important, this step by step process is also important, because this is going to help you to solve a relevant problem in your examination. So let's first start with the one by one. The first one, what you see is that, okay, let me first give you the idea. ddx of x square minus a square, where a is a real number and obviously x is a variable, okay, the variable of integration, that is equal to 1 by 2a into log of mod x minus a by x plus a plus c, where c is a constant of integration. Now that is when you change it to a square minus x square, that is dx by a square minus x square, that is equal to 1 by 2a into log of mod a plus x by a minus x. The third one is that dx by x square plus a square, that is equal to 1 by a into tan inverse of x by a plus c. So whatever you see in the red color, that is dx by x square minus a square, then dx by a square minus x square, then dx by x square plus a square. Now whatever you see in the point 4, 5 and 6, that is actually the square root of whatever we have done in the first 3. That is integration of dx by square root of x square minus a square, and that is equal to log of x plus square root of x square minus a square plus c. Then integration dx by a square minus x square is equal to sine inverse x by a plus c, and finally dx by square root of x square plus a square is equal to log mod x plus square root of x square plus a square plus c. After deriving all these 6, then we will see some special type of integration, and we will see that how we can apply the concepts of this formula to derive those integrations, okay. So this is the entire part. So it may take some time to continue with this one, but we will proceed one by one. In case it is taking a very long time, then I will make this entire session into 2 sub-sessions, okay. The first one is that what is dx by integration x square minus a square. So integration dx by x square minus a square. So what we can do, dear students, here is that, so we can write it here is that integration dx by x square minus a square, we can write is that x plus a into x minus a, correct. Now from here what we can write, dear students, so this is equal to 1 by x minus a plus 1 by x plus a, sorry, here it should be minus, okay, and then I write here it's at dx. Now you can ask that, sir, why you have done so? Because integration of 1 by x minus a is very simple, and that also for integration 1 by x plus a, that's why I write like this. So now if you take a LCM of x minus a and x plus a, so that becomes this one, the previous step, but here it comes x plus a minus x minus of minus a, that means plus a. So that means in the numerator there is a 2a. So to adjust this thing, what we need to make is that we need to make is that 1 by 2a. So we should write 1 by 2a so that it is adjusted. So now what we can do here, dear students, so 1 by 2a, okay, what we get is that this is equal to integration dx by x minus a minus integration dx by x plus a, okay. Now what is integration of dx by x minus a? that is equal to log of mod x minus a. How you can make a substitution? If you want to know that how integration of dx of x minus a is equal to log of mod x minus a, what you can do it here is that, so let x minus a is equal to t. This implies what? Dx is equal to dt, because d of x minus a, that means dx minus dA, that is 0. A is real number, a constant, so that is equal to, so what we get is that integration dx by x minus a is equal to integration dt by t. So that is equal to what? That is equal to log of mod t plus c, and that is equal to log of mod x minus a plus c, where c is a constant of integration, correct? So this is the way we can find that integration of dx by x minus a is equal to log of mod x minus a plus c, correct? In the similar manner, we can get integration of dx by x plus a is also equal to log of mod x plus a plus one integrating constant. Now, if we apply this, what we are going to get it here, dear students? So here we are going to get, so let me clean this portion, okay? I hope you got it. This is a very simple, of steps of substitution. So what we get it here, dear students, so this is equal to 1 by 2a. We get here log of mod x minus a and minus log of mod x plus a, correct? And see, once we complete this integration, that is dx by x minus a, we get one integrating constant. So let's assume that integrating constant is c1, and when we complete this integration, that is dx by x plus a, suppose we get another integrating constant is c2. Now if we mix this thing c1 and c2 and we multiply it by 1 by 2a, finally we get another integrating constant. We can make this as a single integrating constant and we can write this as plus c, correct? So, and where c is a constant of integration, you can write like this. So what we are going to get it is that 1 by 2a into log of, you see that log of m minus log of n, if you recall log of m by n, so that will get log of mod of x minus a divided mod of x plus a plus c, correct? So now what we can write is that 1 by 2a into log of mod x minus a divided by x plus a plus c, correct? So this is the way we derive and this is the formula. Now let's proceed to the next one, that is, so we are done with the first one, okay? Now next one is that dx by integration a square minus x square, okay? So here I write only the denominator, I can change it, that is equal to a square minus x square, a square minus x square. So what we can write it here, dear students? So this is equal to dx by, we can write here is that a plus x into a minus x, correct? A square minus b square, a plus b into a minus b. And this thing, what you can write it here, dear students, so this is equal to 1 by, we can write that a minus x plus, here we can write 1 by a plus x. So let's see what happened. Denominator remains same, a minus x into a plus x, which is there in the previous step. Here you will get a plus x plus a minus x. That means 2a is actually, 2a is extra in the numerator. To adjust this thing, so we will make it 1 by 2a, and that we make it equal. So this dx. I hope it is clear, okay? So now what we are going to do is here, that is equal to 1 by 2a, okay, integration dx by a minus x plus integration dx by a plus x, correct? Now let us concentrate on integration of dx by a minus x. Okay, let's see that how we can find the integration of dx by a minus x. Okay, so what we will do here, so so we are going to do integration of dx by a minus x. So we will assume let a minus x is equal to t. That implies what? Minus dx is equal to dt. So then what we get, this integration is now become integration dx is equal to what? Minus dt divided by t, that is equal to minus of log of mod t plus one integrating constant called c1. C1 is the constant of integration. Now what happened is that minus log of mod t, so what is the value of t? That is equal to minus log of mod a minus x plus c1, correct? So as we found it out, so let us write it here. So what we get here, dear students, so this is equal to 1 by 2a, and here we get minus log of mod a minus x plus c1. Now plus. In the similar manner, we can perform that integration of dx by a plus x. How? Let me show you. So let me clean this particular portion and find that integration of dx by a plus x. So integration of dx by a plus x. So I will take, so we will take let a plus x is equal to t. This implies dx is equal to dt. So now this integration is become integration dt by t, correct? A plus x is t and dx equal to dt. So what is the integration dt by t? So that is equal to log mod t plus another integrating constant c2. So now let's apply back the value of t, that is equal to log of mod a plus x plus c2. So instead of integration dx by a plus x, what we can write is that is equal to log of mod a plus x plus c2. Now dear students, what we get, log of mod a plus x minus log mod of a minus x. That means log of mod a plus x by mod a minus x. So this is equal to, what we can write is that 1 by 2a into log of mod a plus x divided by mod a minus x plus, what will happen, c1 by 2a plus c2 by 2a, that will give you another constant. So we can take this as a final constant called c, that is the integrating constant. So what we get the result here, dear students? So we get 1 by 2a into log of mod of a plus x divided by a minus x plus c, where c is the constant of integration. So we are able to derive the second one as well, dear students. Okay. Now let's proceed for the third one. Okay. So now to proceed for the third one, let me clean this particular portion. Okay, so what we get it here is that integration dx by x square plus a square, dx by x square plus a square. So what kind of substitution coming to our mind, dear students? That is equal to, x equal to a tan theta. Why? Because if we apply x equal to a tan theta, it will be a square tan square theta plus a square. That will become a square sec square theta, and then we'll proceed with the dx also. So let's proceed and then we'll understand. So let x equal to a tan theta. Okay, a is a real number and theta is a variable, so that is the substitution. So from here what we will get, dear students, so if we make a differentiation, dx should be equal to a sec square theta d theta, correct? Because the d of a tan theta, a is a constant, it comes out, so a into d tan theta is what? Sec square theta d theta. So what we get from this integration, this is equal to dx equal to a sec square theta d theta divided by x square plus a square, that means a square into tan square theta, okay, plus a square. So this is equal to what? Integration a into sec square theta d theta divided by a square into tan square theta plus 1, correct? So now this a and a square will get cancelled, and what will get it here? Let me write it here. So we will get 1 by a, and we can take it out of the integration because it is a constant. Then what we get? Integration sec square theta d theta divided by 1 plus tan square theta is equal to sec square theta. Now that sec square theta and sec square theta in the numerator and denominator, that get cancelled because it is not equal to 0. Why it is not equal to 0? Because if sec theta is equal to 0, then this substitution doesn't make sense. So hence it is not equal to 0. So what we are going to get? 1 by a into integration d theta. So that is equal to what? 1 by a integration of d theta is nothing but theta plus c, where c is constant of integration, where c is constant of integration, correct? Now what is theta? We need to apply back the value of theta. So x equal to a tan theta. So that means tan theta is equal to x by a. So from here what we can do? So this implies that tan theta is equal to x by a, and that implies theta is equal to tan inverse of x by a. So we will apply it here. So this is equal to 1 by a into tan inverse of x by a plus c, and this is what is the result, correct, dear students? So we are able to done with the third one. Okay, now let's proceed for the fourth one. So again let me tell you is that all this substitution, whatever I have done, it's based on that your understanding about the basic integration, that how this substitution can help you to find that entire integrand reduces to one which you can easily integrate, and that should be the thought process before making a proper substitution. Okay, and that comes with a practice. If you make more practice, then you will be very comfortable in making the substitution. Okay, now let's proceed to the next theory. Okay, so what it is here? So here the question is that integration of dx by square root of x square minus a square. Okay, so let me write it here. Integration dx by square root of x square minus a square. Now what substitution you can think of? That when square root was not there, it was x square minus a square, and you see that we make into the denominator of product of two expression, x plus a and x minus a, and after that we adjust and perform. But that scope is not here. Okay, why? Because if you make square root of into x plus a into x minus a, after that we really cannot make it is a express in the two separate terms which will be helpful for integration, not possible. So then what we can think of? So we can think of that let that x is equal to a sec theta. Now you can think of that why sec theta. That if we see x square minus a square, then what it will be? A square sec square theta minus a square. So a square into sec square theta minus 1. That means it is tan square theta sec square theta minus 1. So that is why this is the proper substitution. Now if we take x equal to a sec theta, that means what? That means dx equal to a into what? A is constant, we took it out of the differentiation. And what is the differentiation of sec theta? That is sec theta tan theta d theta, we can write, right? So a into sec theta tan theta d theta. So dear students, so if we write it here, so what is dx? That is equal to a into sec theta into tan theta into d theta divided by square root of x square is what? A square sec square theta minus a square. Correct? So what we'll get here is that, so this is equal to integration a into sec theta into tan theta into d theta divided by square root of a square, so it will become a, and square root of sec square theta minus 1, that is equal to square root of tan square theta, that become here is that tan theta. Correct? So what we get here, dear students, so a get cancelled because a cannot be equal to 0. Okay, and tan theta get cancelled. So what we land up with? We land up with is equal to integration of tan theta d theta. Now let me emphasize a little bit. If a is equal to 0, we cannot write this thing, but a cannot be equal to 0. You see, if a is equal to 0, then this substitution doesn't make sense. And in the similar manner, tan theta also cannot be equal to 0. If tan theta is equal to 0, then the substitution doesn't make sense. So hence a tan theta is not equal to 0. Sorry, here you will get, after cancelling that a tan theta, here it is not tan theta, here you will get that sec theta. Okay. So integration of sec theta d theta, that is equal to what? That is equal to log of mod sec theta plus tan theta plus one integrating constant C1. So let's take C1 as the constant of integration. Why so? Because when we replace the value of sec theta and tan theta, we will see that we will get some other constant, and that constant will be mixed with C1 to get another integrating constant called C. So how to do this thing? This is equal to log of mod. What is sec theta? Sec theta is equal to x by a plus what is tan theta? So from here what we get is that sec theta is equal to x by a. That means tan square theta is equal to sec square theta minus 1, sec square theta minus 1, that is equal to what? X square by a square minus 1. So that means tan theta will be what? Tan theta will be square root of x square by a square minus 1 plus C1. Correct? So now if we simplify, what we are going to get is that this is equal to log mod x by a plus square root of x square minus a square divided by a plus C1. So that is equal to what? That we get is equal to log of mod of x plus square root of x square minus a square divided by a plus C1. Correct? So now log of m by n, that is equal to log m minus log n. So what we can write it here, dear students? So that we can write is that log of mod x plus square root of x square minus a square minus log of mod a plus C1. Now that C1 minus log A, that becomes a new constant. So that we can name it as C. So that is equal to log of mod x plus square root of x square minus a square plus C. What is this C? This C is nothing but C1 minus log of mod A. So we can write is that where C is equal to C1 minus log of mod A, and that is a integrating constant. Because C1 is an integrating constant and log A is a constant, so C1 minus log of mod A, that is also a constant, and that becomes a new constant C. So this is what we derive for the formula for point 4. Okay, now let's come to the formula for the fifth one. Okay, so let's see. Okay, so the fifth one is that that integration dx by square root of a square minus x square. So what kind of substitution you can think of here, dear students? So we can think of that let x equal to a sin theta. So this implies dx is equal to a into cos theta d theta, because differentiation of sin theta is cos theta. So now if we apply this value here, so instead of dx we can write a cos theta d theta divided by square root of a square minus a square sin square theta. Correct? So then this a square, if we take it out of the square root, it become a, and that a and a get cancelled. So what we get here is that this is equal to integration cos theta d theta divided by square root of 1 minus sin square theta, that is equal to square root of cos square theta, that is equal to cos theta. So this is equal to integration d theta, because cos theta cannot be equal to 0. Okay, because if cos theta equal to 0, then this substitution doesn't make sense. So then what we are going to get it here, dear students, so that is equal to theta plus c, where c is integrating constant, where c is integrating constant, okay. So now what is theta? So let's look at here, x equal to a sin theta, that means sin theta is equal to x by a, that means theta is equal to sin inverse of x by a. So we can write it here, that is equal to sin inverse of x by a plus c. Correct, sin inverse of x by a plus c. So we are done with the fifth one. Okay, dear students, so now let's proceed to the sixth one. Okay. In the sixth one, dear students, that the integration what you need to perform is that integration of dx by is there square root of x square plus a square. So what substitution comes to our mind is that we can write x equal to a tan theta. so that it will be a square tan square theta. So a square we can take common, 1 plus tan square theta, that is equal to sec square theta, and we can proceed. Okay, so let x equal to a tan theta. This implies dx equal to a sec square theta d theta, correct? So then what we are going to get it here, dear students? So this is equal to integration dx equal to a sec square theta d theta divided by square root of x square is a square tan square theta plus a square, correct or not? So now if you look at that denominator, so this in the denominator, if you look at that a square and a square, you can take outside of the square root, so it become a. Then what we left with, that is equal to square root of 1 plus tan square theta. That means square root of sec square theta. That means once you take it out of the square root, it becomes sec theta. So what we get? A into sec theta. Now this a sec theta in the denominator and a sec theta in the numerator, that get cancelled, and we get, you know, integration of sec theta d theta. Like the previous one, what we can say, that a cannot be equal to 0, then that substitution doesn't make any sense. Sec theta also cannot be equal to 0, then the substitution will not make any sense. So that is why we can cancel a sec theta in the both numerator and denominator. So what we get is that integration of sec theta. And we know what is that integration of sec theta. So that is equal to log of mod sec theta plus tan theta plus one integrating constant C1. C1 is the constant of integration here. Why we took C1? Once we replace the value of sec theta and tan theta in terms of x and a, we will see that one integrating constant will come out. Okay, so we will see this thing. So this is equal to what, dear students? So this is equal to log of mod. What is sec theta? So here what we get is that tan theta is equal to x by a. So that implies sec square theta is equal to 1 plus tan square theta, that is equal to x square by a square. So that means sec theta should be equal to square root of 1 plus x square by a square plus tan theta is equal to x by a plus c1, correct? So now this a square we can take it into that side, and it will be something like this, that is equal to log of mod, okay, what we get is that square root of a square plus x square plus x divided by a plus c1, correct? Simple calculation. Then what we can do it is that this is equal to we can get log of, you know, mod of square root of a square plus x square plus x divided by mod a, correct? Entire thing plus c1, correct? So what you can write? So this is equal to log of m by n, that is equal to log m minus log n. So what we can write? So this is equal to log of mod x plus square root of a square plus x square minus log of mod a plus c1. Now that c1, okay, which is the constant of integration, that and minus log of mod a we can club together and get another constant called c, okay, which we can consider as a constant of integration. Okay, so that we get is that this is equal to log of mod x plus square root of a square plus x square plus c. okay, where c is the constant of integration, and we are done with the sixth formula as well. Okay, so now dear students, that let me complete the session here. In the another session, what I am going to show you that there are some practical integration, something like this, and how to perform that one. Okay, so that will be another session, but I just show you that what kind of integration we are going to perform by using the formula whatever you see in the left hand side. Okay, so the integration should be something like this: dx by ax square plus bx plus c. This is one form. Okay, how to perform that one? So this one form, that we can write it as seventh one. Okay, then eighth one we can write it that integration dx by square root of ax square plus bx plus c. Okay, where abc are real number, and this is a quadratic expression, this is the square root of a quadratic expression, and when we are going to solve the integration of this one, we will take help of this formula, and how, that I will show you in the next session. But I am just informing you, the ninth one should be equal to integration, that is px plus q dx divided by square root of ax square plus bx plus c. Okay, first one what you can do is that we can remove that square root. So the first one, it will be ax square plus bx plus c, and the 10th one is something like this: integration of, okay, px plus q dx divided by square root of ax square plus bx plus c. Okay, so in the next session we will see that how to derive that integration using the formula as you see in the left hand side. So with this note, let me conclude the session here, and we will have our next session very soon. Thank you very much.